Hi, everyone, and welcome to Improving Your Service Mesh Security Model, tips for increasing the security posture of your service mesh using Istio and Gloo Mesh. My name is Eitan Yarmush. I am an architect at solo.io, and I've been working with Envoy, Istio, and many other cloud-native networking technologies for the past 3 years.
Great. And I'm Vennam. I'm one of the field engineers here at Solo. I joined Solo about a year ago. I mostly focus on Istio, Gloo Mesh, and Gloo Edge. But I've been working on Istio for over 3 years now. Before Solo, I was at IBM, where I also served on the Istio steering committee for a couple of years. Yeah, I really enjoy working with customers to help them adopt Kubernetes and Istio. So that's kind of what I do full time now. Today, we want to talk about, mostly narrow down the conversation around security. What are the reasons why people adopt a service mesh, and how they can go about securing and making sure that they are leveraging features that a service mesh offers, and how to structure their environment properly. So at a high level, some of the things we'll cover are, the base use case for a service mesh security, zero trust networking, and then talk about data boundaries and isolation. Eitan will then talk a little bit about certificate management and some of the best practices there when dealing with certificates around application workload certs. And then finally, we'll talk about securing your edge traffic, so kind of traffic that's coming into your mesh. All right, zero trust networking. I think this is a buzzword that is gaining in popularity quite a bit recently, and only seems to be growing more and more. And really, it kind of boils down to our need to solve the complexity that we're now seeing from a switch from monolith to microservice, because we no longer have that simple, clearly defined perimeter boundary for your one application. Now you have all of these various applications, microservices, all talking to one another. There's no clear concept of what a boundary is. There's boundaries around containers, around pods, around nodes, around clusters, regions, etc. So there's now these various boundaries, and people are kind of navigating through trying to figure out what is the best way to secure it. And one of the principles is zero trust posture, where you essentially say that you want a no trust environment, where you want to explicitly be able to give permission on who is allowed to talk to what, and then not assume that just because two applications are in one cluster or one namespace, they're automatically allowed to talk to one another. So we're tightly creating boundaries around every single database or application. Service mesh aims to solve a lot of these challenges that people are looking to address with when they want to implement a zero trust posture in their Kubernetes environment. So as a quick recap of how a service mesh works, essentially a proxy gets injected next to each one of your applications inside the Kubernetes cluster. So if your application is a container that's running inside of a pod in Kubernetes, with the service mesh, you would have a proxy that sits next to that container. The proxy is also a container, and both of these containers would run inside the same pod. And this proxy, Envoy proxy, in the case of Istio service mesh, this proxy is programmed to intercept all incoming and outgoing traffic. And this is really where all of the magic happens. This proxy can start, MTLS communication when talking to one pod from one pod to another pod. So that MTLS encryption and handshake and authentication is all done by the proxy. And then the Istio control plane is responsible for programming these proxies with the logic that you want, whether that's layer 7 traffic policies or authorization policies. You don't have to write Envoy configuration, which can be, kind of verbose and complex. You write Istio configuration, which then Istio control plane will translate that and distribute it to each one of the Envoy proxies. So the main feature that Istio provides in terms of zero trust networking is actually two main features. Is one, this encryption from service to service. So when workload A talks to workload B, the proxy on workload A will intercept that request. It will initiate MTLS connection to the proxy on workload B, and then that proxy will receive that connection, do the MTLS handshake, the TLS termination, and then go on over to workload B. And the beauty of it is that these workloads are now talking to each other using encrypted MTLS traffic without them actually making any change to the source code. So it's all kind of transparent and done in the proxy layer. The second piece is the authorization and authentication flows. So Istio provides a strong identity to each one of your workloads. So workload A has a strong identity, workload B has a strong identity, and then which will allow you to do authorization policies. So policies that say workload A is allowed to talk to workload B, et cetera. And you can get pretty granular when you write these policies. So because Envoy is operating at a layer 7 model, it can understand what the traffic is. If it's HTTP traffic, you can say things like, from this particular service account, I want to allow traffic to this port, in this example, line 19, 9080, you can specify which path and which HTTP verb, and then apply these policies to one or more of your workloads. So with a zero trust network, the way you'd go about implementing it is you would first put down a deny all policy, which means no pod is allowed to talk to any other pod, and then layer all these authorization policies on top. One thing we've learned is that our customers have like a multi-cluster environment, multi-cloud providers, in fact, and writing these authorization policies across multiple clusters or as workloads are moving from cluster to cluster can become pretty complex, and you're writing a lot of policies and constantly having to keep up with what's changing. Gloo Mesh is Solo's, Istio offering, right? It's our Istio enterprise offering. And Gloo Mesh comes with a management plane that essentially does service discovery across all of your remote clusters, and is able to propagate important information from one cluster to another. So things like endpoint data or service information from one cluster to another cluster, so that you can write policies that are multi-cluster. One of the main reasons people adopt this multi-cluster model is so that they can deploy an application across multiple clusters and talk to one another, have applications talk to one another seamlessly without having to go outside the network and come back in through traditional like ingress routes. Instead, applications will just treat the entire across all their clusters as kind of one large mesh, and they're able to talk to one another, fail over from one application to another when the local instance of a service is down, et cetera. The benefit of this when dealing with zero trust network is that you can write your policies in the one management plane and have the management plane translate those policies to lower level Istio's authorization policies and distribute that to each one of your workload clusters. So a policy would look an access policy in Gloo Mesh would look something like this, where you can specify a source and a destination, and then this API is multi-cluster aware. So you can be specific on which cluster you want to apply this on, or if you don't specify a cluster name, for example, in the destination selector, I don't have a cluster name in this example. It gets applied to wherever the product page application currently is living. So Gloo Mesh, the management plane, knows where product page is living, and it's able to apply that policy to product page on that cluster. If tomorrow the developer decides to move that application from cluster 1 to cluster 2, the access policies don't have to change, and that's very key. Another thing that's important is you need to be able to monitor that the policies that you're applying are in fact being applied and they're applied to the right workloads. A dashboard is actually very useful. We've learned that our users are doing is that they would apply access policies and then go check the dashboards to see what workloads it actually got applied to. So that example I showed in the previous slide, you can see that it got applied to the ingress gateway deployment workload as a source and then a destination. And then you can also see which paths, methods, and ports are allowed. A lot of times, the person that is responsible for enforcing these policies might not have the necessary skills to understand, Kubernetes YAML schematics. So for them, a UI like this is greatly helpful to make sure that you do have the right policies in place. There's also, you should also leverage a service graph. A service graph will show live traffic flowing from application to application so that you can make sure that you're applying the right access policies, but also see if you've missed something. A service graph is pretty good in initial implementation of access policies as well. So there's two ways of when you first want to start writing access policies. A lot of users revert to using audit style logging so they can see what traffic is happening, but using a service graph will also cover a big majority of the use case. One interesting feature that we're rolling out with our next Gloo Mesh product, Gloo Mesh release, is the concept of workspaces. This is from us learning how our larger customers are using Istio. They are deploying Istio to large Kubernetes clusters that have multiple teams that are operating on that cluster. And every team is a different independent team that have their own administrator boundaries. There's platform admins and network admins that have their own personas. So there needs to be this tenancy model that's missing in Istio. So with Gloo Mesh, we want to introduce that by this concept of a workspace, which is a logical grouping of, think of it as namespaces that you can, across multiple clusters, that you can group together and say, this is my team A, this is my team B, this is my gateway team. And then you're able to apply policies across all of the workspaces or export and import policies from other workspaces. It's a very exciting and must-have feature that our customers have been asking for quite a bit. So yeah, at SoloCon, we have a full session dedicated to this. The next piece I want to cover is data isolation and boundaries. Working with some of our larger clients, especially the ones in the finance category, they're adopting service mesh because they're trying to meet the compliance requirements from let's say PCI or NIST or FedRAMP. And these compliances essentially boil down to being able to categorize their applications properly, like cardholder data applications need to be dealt with differently than normal traditional non-sensitive applications. They need to monitor how data is flowing, where data is being stored, as well as how traffic is going from one to another. They need to enforce ingress and egress policies to make sure that every application is only talking to who it needs to talk to, and it's not able to talk to anyone else. Especially with microservices, it's so easy to pull in modern microservices, to pull in dependencies without realizing the implications of that. So making sure that the network boundaries are set so that even if something bad does happen, the blast radius is small. So we do a lot of work with our customers to help them build these boundaries even inside of their Kubernetes cluster. So with Istio, the proxy that's next to each one of your application containers is responsible for protecting that application from making any calls that it's not supposed to. But it's not a 100% fail-proof solution. So there needs to be additional policies and network policies that need to be put in place so that if there were to be an application that can get around it, it cannot do some damage. So one of the things that we do is, recommend that your application containers all get an affinity all get scheduled to worker nodes that don't have internet access so that they can't break out and go talk to an external endpoint. And only your ingress gateway and egress gateway pods are scheduled on nodes that have internet access. So making sure that you have your taints and tolerations set in place so that you do have these boundaries. And then for each one of your applications, you have your PCI data node pool and your non-PCI data node pool, and making sure that you need to make sure that you have the right network policies in place so that the hop between one to another is explicit instead of implicit. The problem is only exacerbated when you're dealing with multiple clusters, but it's kind of like a twofold solution. A lot of customers will put all of their sensitive data in a separate cluster altogether, and not rely on like Kubernetes concepts to delineate the two, which is good because now you have this like better isolation. But now you need the ability for one cluster to talk to another cluster, and that also boils down to a set of best practices around how you deploy your ingress gateways, which namespaces do they go into, what's their affinity policy, and making sure that gateways that are responsible for east-west traffic are using a private subnet as opposed to a public one, et cetera. Honestly, like this section alone could be a full talk, but I think in this session, this is more meant to give you, like a high level, things to do that you can then drill down and learn more about later. One interesting use case that we had from a customer is they wanted to span their application workload environment across private and public cloud. So they have their data center Kubernetes clusters and public cloud Kubernetes clusters. And they wanted to deploy applications across the two and have the applications not know where they're sitting and be able to fail over or talk to, back and forth without the applications knowing about their current residence. But, for their compliance reasons, they do have this requirement that there's a DMZ in the middle, and that DMZ is responsible for making sure that the traffic that's going through it, the company needs to be able to inspect that traffic. So we had to, build a solution where this DMZ is a bare metal environment where the only thing they can run is a Docker image and have traffic flow through that Docker image. But they still wanted that image to be able to inspect the traffic if they need to and use it as a kill switch between the two. Thankfully, Istio and Envoy have the building blocks to be able to do things like this. So we were able to build a solution for them to be able to achieve this without their applications, foo, bar, and app even knowing that stuff like this is that there's a DMZ that's happening. And then with that, I'm going to hand it to Eitan to talk about Cert Management.
Thank you so much, Ram. I don't know about the rest of y'all, but I certainly learned a lot. So with that, let's jump into it. So, now that we've discussed boundaries and cordoning off our services by different levels of trust and boundaries, as I mentioned, let's talk about how that trust is actually implemented. And the way that the trust relationships are enforced underlying in Istio is with certificates. And so how do we ensure that we are managing our certificates properly in Istio? Well, to talk about that, let's just briefly talk about how certificates work in Istio, specifically with the MTLS traffic that Rob mentioned earlier, how when the traffic leaves your application, it goes into Envoy, is encrypted, sent to another Envoy, Sidecar, and decrypted. So when the traffic comes through, this is at a high level, assuming you have traffic flowing in through an ingress to a proxy, one through n of them, and then out through an egress. But just to get the lay of the land. So when the traffic comes in, it'll be to the ingress, and then it flows from the ingress to the proxy. So When it does that, again, the traffic is MTLS. So how do those certificates get there? Well, Istio has a CA, and so that's the main way that the certificates are then provisioned to each one of the workloads, that they can perform the handshakes. However, how does Istio get that initial certificate? Well, let's talk about what those look like. Oops. So let's just talk about what those certs look like. So this is drilling down on a specific sidecar or a specific service in our mesh and Istio. So the workflow is like this. Essentially, each service, each Istio, each sidecar is actually a little Go program called the Istio agent. And that Istio agent is actually managing the lifetime of Envoy in the sidecar. And the one other responsibility that that agent has is to send out what's called a CSR, or a certificate signing request. And so what is a certificate signing request? Well, in typical TLS land, that is it has an exact meaning. It's something that is used to sign a certificate. However, in Istio, it is a proto message, which is so an HTTP2 land version of a REST call, which can then be fulfilled by Istio. So when the agent starts up, it essentially will reach out to Istio and say, "Hey, I need you to sign my certificate." However, you don't want the private key going over the wire. So the way it works is the agent is going to generate a private key, okay? And then it's going to send a CSR request to Istio. Istio is then going to fulfill that and send it back. And the important thing is that that certificate that you get back from Istio is going to have the identity. And this is where it ties back to what Ram was talking about all the way back on my slide. So all of our sidecars have an identity. And this is important because to be able to verify who's able to talk to who and where traffic is coming from and going, everything needs an identity. And that identity is encased in the certificate. So again, when Istio receives that request, it then essentially asks the certificate authority, which the certificate authority in a standard Istio deployment, if you were to, let's say, do Istio-ctl install, which is certainly how I install Istio these days, it will create a CA certificate for you. Now, this is not a great idea in any kind of production environment. It's great to start using Istio. However, if your root of trust is generated by Istio, then you don't own it and you will need to rotate it. Right, so there's no real way to rotate it. If someone were to steal it, this is a problem. It's not really secure. It's just in a secret, living on your cluster. There are many issues with it. So that is just the startup and a brief explanation of how the proxy gets its certificate, and then how Istio signs that certificate. However, this is not the only option. As I mentioned, the CSR request that comes from the agent, it's just a gRPC request. So other people can fulfill those requests. One example of doing this is Cert Manager. So those who don't know, Cert Manager is a very popular certificate manager software written by Jetstack, and it has a whole bunch of uses. And one of them is as basically as a target of the CSR. So they have a service which implements this certificate signing request gRPC call. And so instead of the agent reaching out to Istio to have its workload certificates signed, it reaches out to Cert Manager. And you can set this up all using the Istio operator. So what does that mean? That means that instead of Istio managing signing all those certificates and managing the identities of your workloads, instead, Cert Manager is doing that. And that gives us a lot of power because Cert Manager can actually use a bunch of different backends to sign those certs. So in this diagram taken from their website, they're using Vennify. but you can also use Vault or a lot of other external plugins that they let you use. So the flow here, instead of going to Istio-D, you'd go to this Cert Manager plugin. But then, however, you're offloading the certificate signing from Istio-D to Cert Manager. And by Cert Manager, I mean your internal PKI. So there are good things and bad things going on here. One, you're using your own internal PKI, which is good, right? You have your own cert that you use for lots of different services. You have it secured. It's in Vault. It's in Venafi. It's in AWS PCA. There are all sorts of different cloud services out there to manage these certificates. So it's more secure than living on the cluster. However, now all of a sudden, all of your workload certs are getting signed by your internal PKI. So that means that if you were to have a node rollout or any kind of event where lots of workloads need to come up quickly, you could overload your PKI. And that would be really, 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 really bad. So there are benefits to this, but there are also some downsides that really need to be kept in mind depending on the scale of your deployment. So we've definitely taken it a step up. We have ripped out Istio's CA, right? And we've replaced it with our own PKI, but we've also taken a step back because now we can overwhelm our PKI. So let's keep looking about to see what we can do about this. So let's talk briefly about if we didn't want to use Cert Manager, right? As I said, Istio will create that cert secret for us, but potentially I as a user could do that. So we see here, I have some root CA, it doesn't matter where it is, right? I'm going to go get an intermediate CA from that root, and then I'm going to give it to Istio-D. Okay, and that way, again, I am using my PKI as the root of trust. However, Istio-D, that cert is still in a secret. Okay, so there are, again, ups and downs to this approach. And this one can work well for certain situations, especially if you happen to have all of this in GitOps and you have in a single cluster. But right in a second, we're going to talk about how this doesn't scale when you get to multiple clusters. So now we've got multiple clusters, and all of a sudden, I, the user, need to manage signing a whole bunch of intermediate certs and distributing them to my workload clusters. Now, you might say, okay, that's not so bad, right? Like I can do that once, or maybe whenever they need to be rotated, once a year, once every 3 years, however often, you set your cert lifetimes to. But all of a sudden, what if your root's compromised and you need to do a rotation on the spot or anything like that, right? All of a sudden, you're manually worrying about a process that can go wrong very quickly. And when it comes to the security of your applications and the identity of your workloads, that's not something that you want to take for granted or something that you want to be worrying about all the time. So with that in mind, let's talk about Gloo Mesh and how Gloo Mesh can help you solve this problem. So Gloo Mesh ships with a component that we call the Istio-D agent sidecar. Now, what does this sidecar do? Essentially, it's really the best of both worlds. This sidecar lives next to Istio-D. So typically in Istio, the sidecars live next to your apps. Well, we have a sidecar for Istio-D. And how does this sidecar differ from, let's say, the normal Vault sidecar, which can provision secrets? The difference here is that this sidecar will actually communicate. You as a user, you tell Gloo Mesh that you want to connect all of your meshes, right? You want to provision certs from the same root to all of your Istio instances. And our agent sidecar will then go ahead and communicate with Vault. And we will then take that signed certificate, okay, and put it in an ephemeral volume next to Istio-D. So what does all of that get you? Well, all of a sudden now you're managing the lifetime and placement of these certificates from one central place, which is one, that's an amazing benefit. Two, your secrets are no longer your certificates are no longer in a secret. They're in an ephemeral volume. So when your pods restart, they're gone. They're not stored in any database. And three, you've taken the load off your PKI because Istio is still signing all of these certificates. All right. Well, now that we've talked all about certificates and how some best practices and how you can manage them, let's talk about the final frontier of security in a mesh, and that's the edge. So what is the edge? Well, we've talked all about securing the traffic, maintaining boundaries, having identity, ensuring that only specific workloads can talk to each other, using MTLS, using certificate best practices for communicating within a cluster or between clusters, but we haven't talked about traffic coming into your mesh. So typically the way traffic comes into your mesh is with some form of ingress. In Istio, there's the Istio ingress gateway. But there are some unique challenges that need to be solved at the edge. For instance, the requests are usually from known or unknown entities. They're not from trusted entities like inside of your mesh. And so for that reason, we need to worry about things like authentication, external, making sure that the requests that are coming in to the mesh are verified. And number two, we might need to worry about something like rate limiting to ensure that the users are not spamming, right, the services inside of the mesh. And this can be useful inside the mesh as well. Do not get me wrong. But there are unique opportunities for users to overload services externally. So we're going to talk about that quickly and how you can set that up in Istio. So just to briefly discuss what these different strategies are. So external authorization in Istio essentially authorize the request prior to entering the mesh. Now this can come in a few forms. One of these being OIDC. So Auth, let's say you log in with Google, with a Google OIDC, or your organization uses AWS OIDC, any of them, right? When your traffic comes into the mesh, you then get your token from that external source before the traffic makes its way into the mesh. Or you could be an API key, right? Let's say you have a forward-facing API and you have a key that you need to verify, et cetera. And for rate limiting, right, you're limiting the number of requests that clients can make. You ensure that your services don't get overwhelmed. And luckily, Envoy and Istio allow you to do this on many dimensions. For instance, IP, geolocation, et cetera. So what does rate limiting look like? Well, when you rate limit in Istio, essentially, when the traffic comes into the gateway, you have to, as a user, you have to deploy a rate limit server such that the gateway can actually discuss whether or not this request should be rate limited. Okay, so as a user, you have to manage deploying that server as well as configuring it, and then configuring the gateway to speak to it for each request. So in this case, Bob, our little green-hatted man, is allowed 50 requests. So as soon as 51 comes in, he gets rejected. And it's very similar for XAuth. Again, Istio ships with a very simple example of an external auth server, which will allow xallow true in the headers and disallow anything else. So if you wanted to take advantage of the external authorization power of Envoy, you would need to create and deploy an external auth server yourself. But luckily, the API of Envoy is very flexible, so you can implement OIDC or API key, as I mentioned earlier. However, luckily, Gloo Mesh has it ships with all these components out of the box. So as a user, or as a user of Gloo Mesh, you can configure your rate limit policies and your XAuth policies from one place, and your routes will automatically reach out to our provided XAuth and rate limit server. So not only do we offer rate limit servers that are simpler than the ones offered by vanilla Istio, but we also have our XAuth server also offers OIDC, API key, and other integrations. So you can accomplish that all in one place without needing to set it up each time. So just to step back a second and talk about edge traffic. So when we talk about edge traffic, the Istio Ingress Gateway can definitely get you up and running, but it doesn't come with everything that you might need trying to protect or deal with your individual customer use cases. So here we can see that an API gateway has advanced security features like WAF and DLP, so data loss prevention, advanced authentication, transformations, rate limiting, as mentioned earlier, traffic routing and shaping. So these are all different features that allow customers to use these technologies in their own way without being limited by the small subset of features that the gateway that the ingress might ship with. So just as a high level overview of what Gloo Mesh would look like in this case, again, we have our own filters that we ship with in our distribution of Istio. And so those filters can be taken advantage of when designing routes into your system. For instance, as mentioned, data loss prevention. So we can mask sensitive data. We can interact directly with Lambdas. We can transform your traffic, et cetera, et cetera.
Yeah, so this was like a whirlwind session where we covered a lot of topics around things that you need to be thinking about when you're adopting a service mesh and then want to enforce all the features properly. So, if you have any questions on, any one of the particular topics and you want to drill down a little bit more, feel free to reach out to us. Use the solo.io Slack channel. You can find me or Eitan. We'd be happy to go into more details.